As if that wasn't enough, we have what are called Boolean operators. Now, Boolean operators run the risk, because of their name, of being confused with the Boolean data type, which is either true or false. Boolean operators and Boolean data types both come from the same type of logic, which is called Boolean logic. That's the only thing they really have in common. Okay, so Boolean operators are and, or, and not. And there we actually use the words and, or, and not to create even more complicated logical situations. So let me just say up front, this is one of those things that you need to know, but you won't use at this level very often. You need to know that this is something that exists so that you can leverage it, but you don't need to memorize how all of this works, right? Because knowing that it exists allows you to look it up or ask the question or find the answer. And that's a really important thing. So tell me a value for x that would make this true. What is a number I could put in the container x that would make that statement true? It has to be greater than 2 and also less than 10. Anything between the two numbers. 5 would work, yes. So 3, 4, 5, 6, 7, 8, 9, 10, probably inclusive of all of the decimals in between. Tell me a number that would make this true. It's actually anything except 11. Any number in the whole world except 11 would make that true, right? Okay. So this, let me just tell you, if you see x equals 5 and you have a not before it, that's the same as this. All not does is flip what's in here. Okay? So why would we need that? That's crazy. So there are some times when that's the best way to express it. But tell me a number for x, any number but 5, right? Would work. Okay, so back to this one. You read 2 up. We said any number except 11, right? Now it is 11, only 11, or only something greater than 10 and less than 12. If you were talking about whole numbers, oops, what did I just do? There we go. If we're talking about whole numbers, then it would be only 11. But if you were including floats, it would be a whole bunch of numbers. So using that kind of logic, what we could do is something like, if we say, let's say, I'm going to start over here. So let's say I work for a company and I could retire if I'm either 55 or I've worked there for 20 years. Okay? So I would say if int age is greater than 55, or int years is greater than, what did I say, 20? Print, you can retire. Okay, so can I retire? No. I cannot retire. So it will not print. So And I would probably say less than or equal to on these things because once I turn that corner, I could do that. So can I retire now?
Yes.
I can retire. So what if both are true? I can still retire even if both are true because it's an or. Only one of them has to be true, but both of them being true doesn't prevent me from being able to retire.